your modern Ford vehicle has factory-programmed settings designed to quietly destroy your engine long before it ever sees the high-mileage club. Most owners have absolutely no idea that the very features highlighted in the glossy sales brochures are actually ticking time bombs ticking away under the hood, steadily eroding mechanical tolerances until you are left with a catastrophic repair bill. The manufacturers claim these settings are optimized for your convenience, your wallet, and the environment. I am here to tell you, after 15 years of pulling these exact engines apart on my shop floor, that those claims are a corporate illusion. The factory programming is optimized to get the vehicle past the powertrain warranty period and not a single mile further, turning you from a proud vehicle owner into a repeat customer at the dealership service bay. Today, I am exposing the hidden factory settings that are damaging your vehicle without you knowing. Setting number 3 has caused more catastrophic engine teardowns on my lift than almost any mechanical part failure. And setting number 1 is so deceptive that owners actually think it is beneficial when it is doing the exact opposite. If your goal is to see your odometer cross 300,000 miles with the original block intact, you need to understand exactly what these settings are doing to your hardware and how to override them before the damage becomes irreversible. Let's get into it. Setting 5. The Intelligent Oil Life Monitor. Setting 5 is your vehicle's factory-programmed Intelligent Oil Life Monitor, or IOLM. Ford markets this feature as a highly sophisticated algorithm that tracks your driving habits, ambient temperatures, and engine loads to tell you exactly when your oil needs to be changed, often stretching the interval out to 10,000 miles or a full calendar year. They tell you it saves you money on maintenance and reduces environmental waste. But here is what Ford doesn't tell you. That algorithm is programmed around a definition of oil life that only protects the engine long enough to survive the warranty period, completely ignoring the long-term survival of your rotating assembly. When you allow that factory setting to dictate your maintenance, you are inviting severe fuel dilution and mechanical shear to ravage your internal components. On direct injection platforms like the 3.5-liter and 2.7-liter EcoBoost engines, unburnt fuel washing down the cylinder walls routinely contaminates the crankcase. I have pulled oil samples from EcoBoost engines running the factory-recommended 10,000-mile interval, and the lab reports frequently show fuel dilution levels exceeding 5%. That much raw gasoline drops a standard 5W30 motor oil down to a 5W20 or even a 5W15 viscosity equivalent at that point. The oil film thickness between your connecting rod bearings and the crankshaft journals drops below the critical threshold of 2 microns. Without that microscopic cushion of pressurized oil, you experience direct metal-on-metal contact. The damage is cumulative and invisible. It doesn't cause a loud bang tomorrow. Instead, it slowly grinds your engine bearings to dust over 80,000 miles, wearing away the soft Babbitt layer until the underlying copper is exposed. By the time your oil light finally illuminates on the dashboard at the factory-dictated interval, your oil is saturated with microscopic iron and aluminum particles that act as an abrasive polishing paste, wearing down the precise lobes of your camshafts and elongating your timing chains. To get your engine to 300,000 miles, you must completely ignore this factory setting. The fix is a simple change in behavior. Manually reset that monitor and establish a hard, non-negotiable rule of changing your oil every 5,000 miles or 6 months, whichever comes first, using a high-quality full synthetic oil and an OEM filter. Do not let a software code written by corporate accountants tell you how to protect your physical hardware. Setting 4. Factory Auto Start-Stop Engagement. Setting 4 is one that the manufacturer markets as a premier fuel-saving, emissions-reducing benefit, but under real-world conditions, it is creating the exact mechanical environment that destroys your engine's crankshaft thrust bearings and starter components. I am talking about the Factory Auto Start-Stop system, which is programmed to automatically shut down your engine every single time your vehicle comes to a complete stop, whether you are at a red light, a stop sign, or caught in stop-and-go highway traffic. Ford claims this system reduces idle emissions and saves you pennies at the pump, but the catastrophic trade-off occurring inside your engine block is something they completely gloss over. To understand why this setting is so destructive, you have to look at the physics of engine lubrication. When your engine is running at a normal idle, the oil pump maintains a constant hydrostatic pressure, typically between 25 and 35 pounds per square inch. This pressure forces oil into the tight clearances between the crankshaft journals and the main bearings, creating hydrodynamic lubrication. In this state, the crankshaft literally floats on a pressurized cushion of oil, never actually touching the metal of the bearing shells. However, the moment that factory auto start-stop setting kills the engine at a stoplight, your oil pressure instantly drops to 0 psi. Gravity and the immense weight of the rotating assembly immediately squeeze the remaining oil out of those clearances. The engine enters a state of boundary lubrication, meaning the metal surfaces are now resting directly against one another. When the light turns green and you step on the gas, the starter motor forces that dry crankshaft to rotate under the immense load of combustion before the oil pump even has a chance to prime the system and build pressure back up. A traditional vehicle without this setting might experience 50,000 D-start cycles over its entire useful lifespan. A modern Ford equipped with auto start-stop asks the engine to endure that exact metal-on-metal boundary lubrication event up to 500,000 times over the same period. I have personally inspected main and thrust bearings on 3-year-old engines with less than 60,000 miles that looked completely obliterated, loaded with deep score marks and premature wear because they were starved for hundreds of times every single day. Furthermore, the constant thermal cycling cooks your engine bearings, as the sudden loss of coolant and oil flow right after a high-load driving session creates localized hotspots around the turbochargers and cylinders. The solution to this built-in wear mechanism does not require buying aftermarket bypass modules or cutting factory wires. The simple change in behavior is to make disabling this system a mandatory part of your startup routine. Every single time you climb into the cabin, turn the key or push the start button, and immediately press the physical auto start-stop override button on the dash. Make it muscle memory. By preventing the factory setting from dropping your oil pressure to 0 at every intersection, you preserve the hydrodynamic barrier that keeps your rotating assembly spinning smoothly for hundreds of thousands of miles. Those first 2 settings are insidious enough on their own, but they are just the warm-up act for how factory programming actively shortens your vehicle's lifespan. As we climb higher up this countdown, the engineering compromises become significantly more dangerous to your wallet because they strike at components that cost thousands of dollars to replace setting 3. Ultra-low idle speeds and variable displacement control setting 3 is a combined calibration strategy that Ford builds directly into the powertrain control module of their modern V8 and EcoBoost engines. Ultra-low hot idle speeds paired with variable displacement cylinder deactivation. The manufacturer advertises this strategy as a massive win for cabin refinement and fuel economy. They promise a whisper-quiet cabin when you are sitting at a stoplight and a seamless transition to partial engine shutdown on the highway to save you money. But on my shop floor, I see the real-world consequence of this setup, and it is nothing short of mechanical starvation when your engine reaches full operating temperature. The factory programming drops the target idle speed down to as low as 500 to 550 revolutions per minute. Ford engineered this because lower RPMs at a standstill consume less fuel and reduce NVH, vibration, and harshness. But here is the catch that the engineers downplay. Mechanical oil pumps are directly driven by the crankshaft. Their output volume and pressure are directly proportional to engine speed. When the factory setting forces the engine to sit at 500 RPM, the oil pump is spinning at its absolute slowest speed, dragging oil pressure down to a dangerously low 10 to 12 psi now. Combine that low pressure with Ford's variable displacement or cam phaser systems, which rely entirely on oil pressure to function. In engines like the 5.0-liter Coyote or the newer 3.5-liter EcoBoosts, the variable valve timing phasers and hydraulic lifters require a steady, robust stream of pressurized oil to stay primed. At 500 RPM, that 10 psi of pressure is barely enough to push oil up to the cylinder heads, let alone maintain the hydraulic tension required to hold heavy timing chains steady. The oil becomes thin as it absorbs engine heat, and because the volume moving through the upper valve train drops significantly, the oil temperatures in the cylinder heads skyrocket, the invisible, cumulative consequence of this low pressure. High heat environment is catastrophic component failure. The timing chain tensioners lose their hydraulic tight grip, allowing the massive timing chains to slacken and whip violently against the plastic guides. Over time, this constant slapping shatters the guides, sending hard plastic debris down into the oil pan where it clogs the oil pump pickup tube. Simultaneously, the hydraulic lifters and cam phasers begin to clatter and wear down their precise internal locking pins. If that isn't bad enough, when the engine switches into cylinder deactivation mode on the highway, the factory programming shuts off the valves on specific cylinders. This creates a massive thermal imbalance across the engine block. The deactivated cylinders cool down rapidly, causing the piston rings to contract slightly and allowing oil to bypass the rings and bake onto the cold piston crowns as carbon crust. When you ask an engine to endure this cycle for 100,000 miles, you are looking at a top-end rebuild that will easily cost you $3,000 to $5,000. To prevent your upper valve train from being starved of critical lubrication, you need to alter how the engine operates at idle. The solution is simple. Use an enthusiast-grade diagnostic software tool like FEF-RScan or a reputable vehicle programmer to manually raise your hot target idle speed by just 100 to 150 RPM, bringing it up to a healthy 650 or 700 RPM. This minor software adjustment boosts your hot idle oil pressure by an extra 5 to 8 psi, ensuring a continuous high-volume cooling rush of motor oil to your cam phasers and timing components, completely neutralizing the factory-programmed starvation. Setting 2. Transmission skip shift. Programming and delayed downshifts. Setting 2 takes us out of the engine block and drops us directly into the sophisticated electronic controls of your 10-speed automatic transmission. This factory setting is known as skip shift programming, and Ford builds it into almost every rear-wheel drive truck and SUV platform. The manufacturer markets this feature as an advanced, intelligent shifting strategy that skips unnecessary gears during light acceleration to maximize fuel efficiency and provide a smoother, more seamless driving experience. They want you to believe the transmission is simply being smart, but the mechanical reality is that this setting is actively destroying your transmission's internal clutch packs and putting immense lugging strain on your engine. Here is the hidden mechanism behind how this factory setting operates. When you take off moderately from a dead stop, the transmission controller is programmed to shift directly from first gear to third gear, completely bypassing second. Under very light throttle, it will often skip third entirely and jump straight from second to fourth, or fourth to sixth. The goal is to get the transmission into its highest possible gear and its lowest possible engine RPM, as fast as humanly possible to satisfy federal fuel economy standards, but to make these massive gear jumps smooth enough that you don't feel them in the cabin. The transmission control module must intentionally drag out the engagement. It commands the electronic pressure control solenoids to slowly slip the oncoming clutch packs together rather than clamping them instantly. This intentional slippage creates massive amounts of friction and localized heat on the friction plates. Worse yet, because the vehicle is constantly forced into a gear that is too high for its road speed. The engine is perpetually lugging. Lugging means you are applying high throttled percentages at low engine RPMs, asking the vehicle to accelerate from 30 miles per hour while the transmission insists on staying in 7th or 8th gear at just 1/200 RPM. This places an astronomical amount of mechanical load on the engine's connecting rods and main bearings. It causes the cylinder pressures to spike violently, creating a phenomenon known as low-speed pre-ignition, or LSPI. This is where the fuel-air mixture detonates prematurely, sending shock waves through the cylinders that can literally crack piston rings and bend connecting rods in an instant. Inside the transmission, the cumulative damage is devastating. The constant, intentional clutch slippage wears away the friction material, turning your clean transmission fluid into a burnt, black, frictionless soup filled with microscopic debris. Eventually, the clearances inside the clutch packs widen past the point of recovery. You start experiencing harsh engagement, gear hunting, and the dreaded transmission shudder between shifts. By the time you notice the slip, the internal components are already fried, and your only option is a complete transmission replacement, or rebuild, which routinely runs between $5,000 and $7,500 in today's shops. To save both your transmission clutches and your engine's bottom end from this destructive factory calibration, you must intervene. You can easily defeat the skip-shift logic without spending money by altering your daily driving choices. First, whenever you are towing, hauling, or driving through hilly terrain, always press the button on your shifter to engage Taubot haul mode. This factory subsetting completely overrides the skip-shift programming, forcing the transmission to utilize every single gear sequentially and holding onto gears longer to keep the engine in its optimal power band. Second, for daily unladen driving, consider shifting the vehicle into sport mode, which similarly commands sequential shifting and higher line pressures, ensuring the clutches lock together instantly with zero slipping and zero engine lugging. We have unmasked the factory programming that starves your valve train and burns up your transmission clutches, but those pale in comparison to the final setting on our list. This number one spot belongs to a calibration so dangerously deceptive that most owners actively celebrate it as a major benefit, completely blind to the fact that it is doing the exact opposite of what they believe. Setting 1. The deceptive buffered temperature gauge calibration setting number 1 is the factory program buffering logic built into your vehicle's instrument cluster temperature gauge. The manufacturer presents this gauge as a real-time monitor of your engine's thermal health, a reassuring needle that sits perfectly dead center to give you peace of mind while you commute or tow a heavy trailer. They want you to believe that if the engine begins to overheat, that needle will immediately climb to warn you. But here is the brutal reality from someone who plugs diagnostic scanners into these trucks every single day. That dashboard gauge is not a gauge at all. It is a glorified dummy light disguised as a precise instrument, programmed by the factory to lie straight to your face, in a mathematically accurate cooling system monitoring setup. The dashboard needle would fluctuate in real time as coolant temperatures fluctuate. When you climb a steep grade pulling 10,000 pounds, your actual coolant temperature rises. When you descend or sit at a light, it drops. However, Ford knows that real-time fluctuations cause panic among average consumers who do not understand mechanical thermal cycles. Their solution was to program a massive electronic buffer or dead zone directly into the gauge software. When your engine coolant temperature is at a perfectly healthy 195 degrees Fahrenheit, the needle sits right in the middle. But if your cooling system develops a slow leak, a sticky thermostat, or a clogged radiator, and the temperature climbs to 215, 220, or even 230 degrees Fahrenheit, the needle on your dash will not move a single millimeter. The factory programming intentionally forces the gauge to lock itself dead center across an astronomical window, frequently all the way from 185 to nearly 235 degrees Fahrenheit. This means your engine can be running dangerously hot, softening its aluminum cylinder heads and pushing its head gaskets to the absolute brink of failure, while you drive down the highway completely oblivious, thinking everything is operating perfectly. The needle will only jump into the red zone and flash a warning light after the coolant temperature crosses a catastrophic threshold, usually around 240 to 245 degrees Fahrenheit. By the time that factory setting allows the gauge to tell you the truth, the damage is already done. Aluminum expands at a much faster rate than a cast iron or graphite iron engine block. When the cylinder head temperatures spike into that hidden 230-plus zone for extended periods, the head physically warps, distorting the combustion chamber sealing surface by thousandths of an inch. This microscopic warping crushes the multi-layer steel head gasket, allowing high-pressure combustion gases to burn through the sealing rings and enter the cooling jackets. The consequence is a sudden, catastrophic blow-by event that pressurizes your cooling system, blows coolant out of the reservoir, and mixes coolant directly into your engine oil. I have torn down dozens of modern engines with warped heads and blown gaskets where the owner swore up and down. The truck never overheated. The gauge was right in the middle until it suddenly died. The gauge didn't catch it because the factory programming actively hid the truth until the metal reached its melting point. A head gasket and cylinder head machining job on a modern overhead cam Ford engine is a nightmare scenario, easily running between $4,000 and $6,000 at a reputable shop to get your vehicle to 300,000 miles. You cannot rely on this deceptive factory dashboard display. The solution is an immediate change in your monitoring habits. You must bypass the buffered factory gauge entirely by installing a dedicated digital monitor that plugs directly into your vehicle's OBD2 diagnostic port, such as an Edge Insight, a ScanGauge, or even a digital dash layout via the FORScan mobile application. These devices read the raw, unbuffered data directly from the engine coolant temperature sensor and cylinder head temperature sensor before the factory cluster software has a chance to sanitize it. Seeing the actual numbers allows you to pull over and address a cooling issue when the truck hits 222 degrees, saving your cylinder heads from warping and completely sidestepping a multi-thousand-dollar engine teardown. Conclusion: when you look at the entirety of these 5 factory settings, a very clear picture begins to emerge. Your vehicle is not engineered to fail mechanically from the factory. The physical hardware, the blocks, the forged rods, the robust cranks, is actually capable of incredible longevity. Instead, the vehicle is engineered to fail through its software calibrations. The 10,000-mile oil life monitor, the relentless auto start-stop cycles, the starved idle speeds, the slipping transmission skip shifts, and the blinded temperature gauges are all digital parameters designed to extract maximum short-term efficiency metrics at the direct expense of long-term mechanical durability. The manufacturers have optimized these vehicles for the first owner who eases the truck for 3 years and turns it back in. But if you are the owner who wants to keep your hard-earned money in your bank account, avoid the service drive and watch that odometer roll past 300,000 miles. With the original powertrain intact, you have to take control of the machine. You cannot be a passive driver who relies on factory defaults. Take the actionable steps we discussed today. Change your oil strictly at 5,000 miles to fight fuel dilution. Make disabling the auto start-stop a non-negotiable part of your startup routine to save your main bearings. Raise your hot idle RPM to keep your cam phasers swimming in pressurized oil. Use tow haul or sport mode to force your transmission to use every gear without slipping its clutches. And finally, get an aftermarket digital monitor on your dash so you can read the true thermal health of your engine in real time. The difference between a Ford engine that hits the scrap heap at 120,000 miles and one that quietly rolls past 300,000 miles isn't Luke K. And it isn't a secret assembly line. It is an owner who took the time to understand the hidden mechanical realities under the hood and chose to drive and maintain their ordinary truck exceptionally well. If you are ready to take control of your vehicle's lifespan and beat the factory timeline, hit that subscribe button, tap the notification bell, and leave a comment below telling me which